Hello, grade 9 learners. So this topic is about solving radical equations. The learning competency for this topic is that the learner solves equations involving radical expressions. So let's have this drill. So find the solution or solutions of the following equations. So number 1, we have x plus 7 equals 12. So what will be the value of x? So it will be 5. So we have here to get the additive inverse of positive 7. So it will be minus 7. So 12 minus 7 is equals to 5. Number 2, we are going to get the multiplicative inverse of 3. So divide both sides by 3. The answer is negative 8. Number 3. So first we are going to get the additive inverse of negative 4. It will be positive 4. Then divide both sides by 2. So the answer is 10. Number 4. Okay, so this is x squared equals to 144. So we will get the square root of both sides. The answer is positive negative 12. And number 5. Okay, so we are going to divide both sides by 2. Okay, so the answer is 9. So get the square root of both sides. The answer is positive negative 3. So write each expression in radical form. So remember, this one is in rational exponent. So how to get this in radical form? Okay, so remember, the numerator is our exponent and the denominator is our index. So number 6, x plus 6 quantity raised to 1/2, it will be equivalent to square root of x plus 6. Number 7, quantity 3y plus 4, close quantity raised to 3/5. So our index will be 5, our exponent will be 3. Okay, and number 8, quantity x plus 2, close quantity 3 over 3. So the answer is cube root of x plus 2 quantity cube. Okay, so this is how are we going to write a rational exponent to radical form. The objective of this video lesson is to solve a radical equation, solve word problems involving radical equations, and appreciate the use of radical in real life situation. Okay, so before we start with our examples, let's define first some vocabulary that we are going to encounter in this lesson. So the first one is a radical equation. So what is it about? So it is an equation containing radicals with variables in the radicand. So remember, here are the examples. So we have square root of x equals to 6. So if we notice, there is a variable inside the radical symbol. Next, square root of x plus 5 equals 3. Okay, so you notice there's another variable here. Okay, and this is a binomial. Next is cube root of x minus 4 equals to cube root of x. So we have here a variable x in both sides of our equation. And what is a solution? A solution to a radical equation is a real number which when substituted for the variable gives a true equation. And what is an extraneous solution? It is a solution that does not satisfy the given equation. So, in radical equation, we might find an extraneous solutions. Okay, here are the steps in solving radical equations. So first step is we are going to isolate the radical. So for example, here we have cube root of x minus 2 equals 0. So here we are going to isolate this by getting the additive inverse of negative 2. So it will be positive 2. So when we say isolate, okay, so we let this remain in one side of your equation. So we get the additive inverse of negative 2. Okay, so it will become 0, and then here we equate it to 2. So next, raise both sides of the equation to a power equal to the index of the radical. So here our index is 3. Okay, it's a cube root of x. So it means we are going to raise both sides of the equation to cube. Now, so why is it that we raise it to the same to the power equal to the index? So that this will be 3 divided by 3 is 1, meaning an nth root, okay, raised to n will be equals to the radicand itself. Okay, law of radicals. So we have here number 3, simplify and solve. So we have cube root of x raised to cube will be equal to x. Then cube root of 2 will be equal to 8. So the value of our x is equal to 8. Then remember, for a square root, the index of the radical is 2. So remember, we don't write 2 in a radical symbol. It is understood that it is square root, or the index is 2. Okay, so let's have some examples of solving radical equations. Example 1. Solve square root of x equals to 6. So we have here, first we are going to isolate, but remember it's already containing square root of x, meaning it's already isolated. So second is we are going to raise to a power. So if the index here is 2, meaning we are going to raise to square, or 2. So square both sides of the equations. Now, so meaning here 2 divided by 2, because it will be x raised to 2 over 2. So it will be x equal to x. So x is equals to 36. Now, to check, we are going to substitute the value of x to the original equation. Okay, so we have square root of 36 equals to 6. Then square root of 36 equals to 6 equals 6, meaning it is true. So the value of your, or the solution of the given equation is 36. Let's have example number 2. Solve square root of x plus 2 equals to 3. Okay, so the first step is we're going to isolate. So it's already radical in one side of your equations. It's already isolated. So next, raise both sides into the power equal to the index. So the index is 2. So we are going to raise both sides to square. Okay, so square both sides. Now, so it means 2 divided by 2 is equals to 1. So it means it will be x plus 2 equals to square of 3 equals to 9. Then we are going to simplify. So when we say simplify, we are going to transpose this. So get the additive inverse. It will be minus 2. So the answer is x equals to 7. Now, to check whether the solution is correct, we are going to substitute it to the original equation. So, let x equals to 7. So, 7 plus 2 equals to square root of 9. And square root of 9 is equals to 3. So, 3 equals 3 is true, meaning this is the solution of our radical equation. Let's have example number 3. So solve square root of 3x plus 2 equal to square root of x plus 10. Now, so here we have radicals in both sides of our equation. So it means we're going to raise both sides of the equation to the power equal to the same index. So it is 2. So square both sides. Now, so 2 divided by 2, okay, equals to 1. So it will be 3x plus 2 equals to x plus 10. So here we are going to simplify by combining like terms. So we have here, okay, x minus x. So we subtract x both sides, then subtract 2 both sides. So we have here 3x minus x will be 2x equals to 10 minus 2 equals to 8. So here this one is already equal to 0. So divide both sides of the equation by 2. The answer is 4. So this is the solution of our equation. So let's find out whether it is correct. So to check, substitute the value of x to the original equation. So we have 3 times 4 plus 2. So this is 12 plus 2 is square root of 14. On the other side, 4 plus 10 is equals to square root of 14. So they are equal, meaning this solution is correct. Let's have example number 4. Solve x minus 6 equals to square root of x. Now, so here, since this one is square root, we are going to raise or square both sides of the equation again. So by squaring, this will become 2 divided by 2, it will be equal to x. So this one, we are going to use a square of binomial. Okay, by squaring a binomial, we have square of x, x squared. Negative 6 times x will be negative 6x times 2. It will be negative 12x. Negative 6 square is positive 36. Okay, then we are going to combine like terms. So we have x squared minus 12x minus x, because we get the additive inverse of positive x, plus 36. So this will become 0. So we have x squared minus 13x plus 36 equals 0. Now, So from this quadratic equation, we will get the factors. So what are the factors? Wherein the product is 36, the sum is negative 13. So we have 9 and 4, both negative. So we have quantity x minus 9 times quantity x minus 4 equals to 0. These are the factors. So we have two solutions, x equals 9 and x equals 4. From these two solutions, we are going to check whether these two solutions are true to our original equations. So let's check. So if x equals to 9, okay, we are going to substitute 9 minus 6 equals to square root of 9. So 9 minus 6 is 3 equals to square root of 9 is 3. So this is true. Now how about if x equals to 4? So we have 4 minus 6 equals to square root of 4. 4 minus 6 equals to negative 2 equals to square root of 4 is positive 2. If we look at, they are not equal. So meaning x equals 4 is our extraneous solution, meaning it will not justify our equation, meaning this is extraneous. This one is the solution. So therefore we can say that x equals 9 is the only solution and x equals 4 is the extraneous root. Extraneous solution is a solution that does not satisfy the given equation. Okay, so that is the meaning. Okay, let's have example number 5. So we have here cube root of 3x minus 4 equals 2. So if our index is 3, meaning we will raise both sides of our equation to cube. Now, so 3 divided by 3 equals 1. So, and here, okay, 2 cube is equals to 8. Okay, so simplify, 3x minus 4 equals 8. Now, okay, we will get the additive inverse of this. Okay, combine the like terms. So we have 3x equals to 8 plus 4 equals 12. So divide both sides of the equation by 3. The answer is 4. So let's check whether our solution is correct. Now, so here we have 3 times 4, 12 minus 4 is equals to 8. So cube root of 8 is 3. 3 equals 2. Cube root of 8 is 2. So 2 equals 2 is correct. Let's have example number 6. Solving equation with rational exponent. What if the given is in rational exponent? So this one, we are going to change it into radical form. So this is equivalent to cube root of 5x plus 7. So remember, the denominator is your index. So equals to 3. Now, so we are going to write or raise both sides of the equation to cube since our index is 3. So 3 divided by 3 is 1. So we have, simplify, we have 5x plus 7 equals to cube of 3 equals to 27. Then combine like terms, get the additive inverse, it will be minus 7. So we have 5x equals to 20. Okay, now then we are going to solve for x. Divide both sides of the equation by 5. The answer is 4. Okay, now, so that is how we solve for radical equations. So let's have now the applications of solving radical equations. So when we say application, we are going to use now and real life problems. How to solve radical equations. So we have here a situation. A woman bikes 5 kilometers the east going to school and then walks 9 kilometers northward going to church. How far is she from the starting point, which is her house? So this is the illustration. Okay, so this is the distance, 5 kilometers going to the school, then 9 kilometers going to the church. Okay, so the question is, what is the distance of this from the starting point going to the church? Since the illustration is a right triangle, we can apply c squared equals a squared plus b squared. This is a Pythagorean theorem, which is applicable to a right triangle. So, Pythagorean theorem states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides. So we will use this formula to find this distance. So let's identify the given. So we have, let A equal to 9 kilometers and B equals to 5 kilometers. So we will find out the distance of C, which is the hypotenuse of a right triangle. So these are the two sides. So using the formula, c squared equals to a squared plus b squared. So we will get the square root of both sides. So we have c is equals to square root of a squared plus b squared. So let's substitute the given. Okay, so we have A equals to 9 kilometers and B equals to 5 kilometers. So square. So we have 9 square is equals to 81 kilometers square plus 5 square is 25 kilometers square. Then simplify, we have 81 plus 25 equals to 106 kilometers square. So C is equals to square root of 106 kilometers. So this means that the woman is 106 kilometers from her house, or approximately between 10 kilometers and 11 kilometers. So let's have another application. What is the measure of the diagonal of a rectangle with a length of 4 cm and width of 3 cm? So let's identify the given. A equals to 4 cm and B equals to 3 cm. So we will find out what is the measure of the diagonal of our rectangle. So we will use again the Pythagorean theorem. C equals to square root of a squared plus b squared. Substitute the given. So we have 4 squared is equals to 16 centimeters squared plus 3 squared is equals to 9 centimeters squared. Then we are going to find the sum. 16 plus 9 is equals to 25 centimeter square. So simplify, C is equals to 5 centimeter. So the value of our diagonal, or the measurement of our diagonal, is equals to 5 centimeter. Okay, find the perimeter and the area of a rectangle shown in the figure. Okay, so we have another triangle. So the length is 11 square root of 11 centimeter and the width is square root of 3 centimeter. So for the perimeter, we have the formula 2L plus 2W, meaning 2 times length plus 2 times W, or width. Okay, so let's identify the given. Our length is a square root of 11 centimeter and our width is square root of 3 centimeter. So multiply this by 2. So we have 2 times square root of 11 centimeter and plus 2 times square root of 3 centimeter. So since they are not the same or similar radical, we cannot combine. So meaning this is our final answer. For the area, okay, we have the formula length times width. So simply multiply the length, which is square root of 11 centimeter, by square root of 3 centimeters. So the answer is square root of 33 centimeters square, and this is our area for this rectangle. So I hope that you learned something from this video. Thank you for watching. Bye.